All right, continuing on with the 5.5 section. A few other problems we'll look at would be this one here, and we want to use the half angle formula to figure out the exact value of the, well, let's go with sine of 165 degrees. So for sine of 165 degrees, you would have to figure out, well, let's see, what angle can you take half of to get to 165? And that would be the sine of 330 divided by 2. And then from that, we know that sine of a half angle is plus and minus the square root of 1 minus cosine of x over 2. And in this case, our x is 330 degrees, and cosine of 330 degrees, which is this angle right there, is a positive square root of 3 over 2. So you're going to have plus or minus the square root of 1 minus the square root of 3 over 2 over 2, which then multiplying by 1/2 is going to get you plus and minus the square root of 1 or 2 minus the square root of 3 over 4. Now how to get that? Well, if you put this underneath each of these two things, you're going to get to have 1/2 minus the square root of 3 over 4, and then this has to turn into 2/4. So then we can take the square root of the denominator, and so then that turns into the square root of 2 minus the square root of 3 all over 2. Now 165 degrees is in this quadrant, and therefore sine is positive, so we would use the positive angle here. Now if we're going to do cosine, that would be the cosine of 330 divided by 2, and the cosine rule is 1 plus cosine of x over 2 square root plus and minus. And let's see, the cosine of 330 is square root of 3 over 2 again. So we have 1 plus the square root of 3 over 2 square root plus minus. Difference with this one is a 1 plus, and so this, like up here, or like right here, same problem, except now this is a plus sign instead of a minus sign. So therefore it's going to be 2 plus the square root of 3 over 4 square root plus and minus. And then you can take the square root of the denominator again and get 2 plus the square root of 3 square root over 2. And because 165 degrees in this quadrant, cosine is negative in that quadrant. And finally, tangent of 330 over 2. And let's see, we're going to use this one that has a single denominator, cosine of x over sine of x. Actually, it's 1 minus. So that turns into 1 minus the square root of 3 over 2 over, and let's see, the sine of 330 degrees is a negative 1/2. And then if you multiply by the reciprocal of a negative 2 over 1, it's going to turn into a negative 2 plus 2, the 2's divide out, so square root of 3. And there's tangent. All right, moving on to the next question. Cosine of u is 7/25 and u is here. Same thing. Let's do tangent first. Tangent of u over 2. And let's see, we're going to use, still want to use the one where we got the 1 in the denominator. So 1 minus sine u over cosine u. Isn't that it? No. It's 1 minus cosine over sine. And so now this is, we know cosine is 7/25, so 1 minus 7/25 over, and sine we've got to figure out. So we've got to do this, and that's u, and cosine is 7/25 and makes that 24. So sine is going to be 24 over 25. All right, so then that's like 25 over 25, and 25 minus 7 is 18 over 25, multiplied by 25 over 24. Hey, and the 25s can divide out, and 6 goes into 18 and 24. 3/4. Now, if you noticed from the earlier stuff, hey, that was the same, kind of the same type of problem. We'll go through the rest of it though. Sine of u over 2. Is plus and minus square root of 1 minus cosine x over 2. And we know that cosine is 7/25, so we have plus or minus square root of 1 minus 7/25 over 2. And that turns into, let's see, 25 over 25 minus 7 over 25 is 18/25 over 2. And that turns then into plus and minus square root of 9/25. And the square root of 9 is 3, and the square root of 25 is 5. And because our angle to begin with is in the first quadrant, and half of that would still be in the first quadrant, so it's plus 3/5. And hopefully you know that cosine is 4/5 at this point, because it's a 3, 4, 5 triangle. But let's go through it. Cosine of u over 2 is equal to plus and minus square root of 1 plus cosine of x over 2. And that would be plus and minus square root of 1 plus 7 over 25 divided by 2. And 25/25 plus 7/25 is 32/25 divided by 2, which then becomes 16 over 25. And the square root of 16 is 4, and the square root of 25 is 5. And again, it's positive because we're in the first quadrant, so it's 4/5. All right, here we have to use our identities to simplify to a single term. Now, this one looks like, hey, it's 1 plus cosine of something over 2, which is, from our half-angle identities, cosine of x over 2. This being x, so that turns into 4x. And 4x divided by 2, because this you can do some math with it, and that's cosine 2x. And then moving on, solving this equation. We have another half-angle identity, tangent of x over 2, which can become 1 minus cosine of x over sine of x, or you can choose sine of x over 1 plus cosine of x. Now, which one do you want to use with this one? I think probably the one on the left would be a better choice for it, because that has a single denominator. So we're going to turn that into 1 minus cosine of x over sine of x minus sine of x equals 0. And now, because we have a denominator, let's multiply the entire equation by sine of x. This would turn into 1 minus cosine of x. And then minus sine squared of x equals 0. Now then we have stuff here, and by your Pythagorean identity, if we switch the order, we'd get a negative cosine of x, and then plus 1 minus sine squared of x equals 0. Why do we want to switch the order? Well, this we know is equal to cosine squared of x. And now that we have that, by your factoring properties, they both have a cosine in them, so let's factor out a cosine. It would be a negative 1 plus cosine of x equals 0. And then cosine of x equals 0, and a negative 1 plus cosine of x equals 0. In this case, x is equal to the inverse cosine of 0, and cosine is 0 here and there. So pi over 2 and 3 pi over 2. In this one, you add 1 and get cosine of x equals 1. So x is equal to inverse cosine of 1. And where's cosine 1? Right there. 0 degrees at 2 pi, at 4 pi, and so on and so forth. Now, because the directions said nothing as far as that is concerned, general form of this would be, because these are every pi over 2, not every pi over 2, every pi, start with pi over 2 and add pi n, because if you start there and then add pi to it, you're going to get to that one, and add another pi, you get to that one, another pi, you get to that one, and if you subtract pi, you go that way, and that's why pi n, and n is an integer, positive or negative. In this one, because you start at 0, it'd be 0 plus, and it's every 2 pi n. So that means you start here, and then you go around, and you go around again, and so on and so forth, and whether you go that way or this way, doesn't matter. And 0 plus 2 pi n is just 2 pi n. Now, if it had given you an interval, say bracket 0 comma 2 pi, parenthesis, then your answer would be pi over 2, 3 pi over 2, and 0, because it includes 0, not 2 pi. And these would be the only solutions then. All right, moving on to the next one. We have to write this as a sum. Well, this, because it's multiplication of things, would be considered a product. And we have to turn it into a sum. So we are going to use the product to sum identities, which this one is sine cosine, and that is the second one down. Sine x cosine y, which is 1/2 sine x plus y, and plus sine x minus y. can still have the 6 there. So sine of x plus y, x is 45 degrees, y is 15 degrees. So 45 and 15 and 45 and 15. And 45 plus 15 is 60. So hey, we can multiply 6.5. That's 3 times sine of 60 plus, and 45 minus 15 would be sine of 30. Now we do not have a sum yet because we have this 3 on the outside of our parentheses, so we distribute the 3 to both of those things, get 3 sine 60 plus 3 sine 30. There's a sum. Now if it actually asks you then to evaluate the exact value of this thing, well, this you could, hey, do a half angle formula for this, because that's 30 degrees divided by 2, and then figure out all of that and multiply it all together. Or here we can just do this, and hey, sine of 60 is the square root of 3 over 2 times 3, and the sine of 30 is 1/2. And then this would be 3 square root of 3 over 2 plus 3 over 2. That's 3 times 1/2, that's 3 halves. And so there would be the exact value if you were trying to find the exact value. Well, we were just trying to write as a product or a sum, so there's our final answer. And this one says write as a product. So now we want to take a sum to product identity. And we have sine of x and sine of y, so that is the first one, which is 2 sine x plus y over 2 times cosine x minus y over 2. And in this case, x is x and y is 7x. So this is x plus 7x and x minus 7x. All right, so x plus 7x is 8x divided by 2 is 4x. And cosine and x minus 7x is a negative 6x divided by 2 is negative 3x. Now this one here has some more that we can do with it, because cosine of a negative 3x from our even odd identities, cosine of a negative angle is equal to cosine of an angle, so this can just be turned into cosine 3x. And then sine of 4x and 2. And here then is our product. And that is everything dealing with section 5.